Hello, good afternoon. Now today I start new chapter, important chapter, that is the spectroscopy. Spectroscopy. In other form you can say molecular spectra. Molecular spectra. In case of structural determination, we use so many chemical and physical methods to know about the structure of any unknown organic molecules. So this spectroscopy is also one of the very useful methods by which we can determine the structure of the organic molecule, even some of the inorganic molecules. So actually, what happened? Just see. We use electromagnetic radiation. Electromagnetic radiation means light which has electrical field as well as magnetic field, and that's why it is called as the electromagnetic radiation. So actually, whenever light incident upon the molecule, either in the form of solid or in the form of solution or in the form of the gas, some amount of the energy, light energy is absorbed, some is transmitted. So all these phenomena can be used to determine the molecular structure. So there are different types of the spectroscopy method. For example, you can say UV means ultraviolet spectra. Ultraviolet spectra. We shall discuss about the ultraviolet rays. So in this spectra we use a high energetic wavelength, that is near about 200 to 380 nm, 200 nm to 380 nm or 400 nm. And there is another region of the ultraviolet, that is the far UV region, which is very energetic region, means wavelength has high energy, short wavelength. So in structural determination, this wavelength is not very useful. So we shall study about the ultraviolet spectroscopy. Now second is the IR spectra. IR spectra. In the IR spectra, we can study about the functional group. You know, in the molecule there are bonds, different type of the bonds, single bond, double bond, triple bond, sigma bond, pi bond. So all bonds they have some energy, means some energy associated with the chemical bond. When light is absorbed by the molecule, there is a vibration in the bond. Vibration may be stretching vibration. Stretching vibration may be symmetrical or asymmetrical, we shall discuss. Vibration may be bending vibration like this. So all these have characteristic frequency, and we measure those characteristic frequency and we can determine the nature of the bond. Exactly in case of the group, suppose any organic molecule has OH group, amino group, carboxylic group, carbonyl group. So how we can identify that organic molecule has some particular type of the group? So we shall study in the IR. So in this spectroscopy, we use IR region wavelength. Here means 800 angstrom to higher area. Now, third type of the spectra is the Raman spectra. Raman spectra. Raman spectra. In this spectra, when some of the light incident upon the molecule or the substance, so scattering takes place. Scattering. Some of the light wave can transmit and some can scatter. So in Raman spectra, we shall study about the scattering of light. Depending upon the scattering of light, we can have idea about the molecular structure. So this spectroscopy is very popular because the conventional scattering of light is the Rayleigh scattering. Rayleigh scattering. But Raman studied that there are few scattered light, which are very few, that may be Stokes line or anti-Stokes line. And since it was studied by the Raman and therefore the spectroscopy is known as the Raman spectroscopy. There is another type of the spectroscopy, that is the NMR, NMR spectrum, NMR spectrum, nuclear magnetic resonance, nuclear magnetic resonance, nuclear magnetic resonance. In most of the cases, we understood about the electronic resonance, but every atom has nucleus. Nucleus we have as a tiny magnet. It has its own magnetic field. When we apply magnetic field from outside and object that the field of the proton or nucleus, when resonate with the external field, we get certain type of the signal. So on the basis of the signal, we can understood about the molecular structure or type of the nuclei present in the molecule. So here, these are the different type of the spectra which are used to determine the molecular spectrum. But here we shall discuss only three spectra: UV spectra, ion spectra, and Raman spectra. Now we shall not study about the nuclear magnetic resonance spectra. We shall not study. So now let us start UV spectra. UV spectra. So before, so just see there are different regions of the light radiation. Which is you say electromagnetic radiation. Just see here. This is far UV region. Ten to 200 nm. Second is the UV region. UV region. It is 200 to 380 nm. And this is the visible region. And this is the IR region. IR region. So, the whole electromagnetic radiations are classified in different regions. This region has high wavelength, low energy. This region has a moderate energy and less wavelength than higher region. All colors, violet to red, they have wavelength under this region, and this one, why this is known as the visible region. Dicta, I can see what is the violet, what is the red, what is yellow, what is blue. So all colors are visible, and therefore this is the visible region ranging from 380, sometimes you can say 400 nm to 800 nm. Now just below, again wavelength is shorter than visible. This is known as the UV region, 200 nm to 380 nm. This is the far UV region, very high energy containing wavelength. इनकी एनर्जी बहुत ज़्यादा होती है, इसीलिए ये हमारे किसी भी स्ट्रक्चर डिटर्मिनेशन में काम नहीं आती. So this is all about the different regions of the electromagnetic radiation. Now second thing, when some electromagnetic radiation or light incident upon the molecule, either in solid form or in liquid form or in gas form, absorption may take place. Absorption may be of high quantum or low quantum, that is immaterial. But one of the phenomena is that some part of the light is absorbed and rest of the light is transmitted, emitted, you can say. So there must be some law. लाइट के एब्जॉर्ब होने के कुछ नियम बताए गए, उन्हीं नियमों के आधार पे एब्जॉर्प्शन होता है. जैसे इसको कहते हैं लॉ ऑफ एब्जॉर्प्शन, मीन्स एब्जॉर्प्शन ऑफ लाइट. तो इन case of organic compound, if I say that light is absorbed, so Lambert law, Lambert. According to this law, absorption या molar absorptivity, molar absorption A, it is equal to log I0 upon I. This is one of the law, Lambert law. So one can say what is I and what is I0. You can say I0 intensity of incident light. Incident जो लाइट है पड़ रही है, ये दिस इज द इंसिडेंट लाइट. आफ्टर absorption, some of the light may be transmitted. So you can say this it is intensity of scattered light. Scattered light. Scattered. So two phenomena take place when as soon as light is incident upon the molecule, some part of the light is absorbed by the molecule, and the light which is not absorbed by the molecule, that is the transmitted. So in this way, if there is a more absorption of light, less will be I. If there is a less absorption of light, so I will be higher in comparison to other. There is another term also, transmittance. T, it is equal to I upon I zero. T, it is the transmittance. Transmittance. So transmittance means ratio of transmitted light to the transmittance means ratio of intensity of the transmitted light to the intensity of the incident light. So this is the absorption, molar absorption, and this is the intensity of the incident light, and this is the intensity of the transmitted light. So this has been explained by Lambert. But there is another law also. Another law is Beer's law. Beer's law. Beer's law. According to Beer's law, absorption of the light depends upon concentration and thickness of the solution. Suppose there is a tube, there is a tube like this. This is the tube containing the solution. So the length, this is the L, concentration is C. So according to Beer's law, A means absorption of light, it is proportional to C. It is proportional to C. Also, A proportional to L. What is L? Length of the light. So this is the thickness. कितना दूरी तक ये लाइट जा रही है, जितना दूर तक ये जाएगी तो एब्जॉर्प्शन ज्यादा होगा. So one of the thing is thickness of the solution. So that is in terms of length of the solution. So absorption is proportional to concentration. So here you can say C concentration. Concentration. What is real length? Length of tube. Length of tube or thickness. So we can say A or you can say A proportional to C into L, or you can say A is equal to epsilon C into L. Epsilon. What is epsilon? Epsilon is extinction coefficient epsilon is extinction coefficient. You can say epsilon molar extinction coefficient. Molar extinction coefficient. Commonly, the value of this epsilon for maximum, sometimes this is also called as the adaptivity. So you can say for most of the cases the value of epsilon is this much. This value. We shall study about the all factors. Just see if C is equal to 1, L is equal to 1, then A is equal to epsilon. So in this way, when C concentration means 1 mole, concentration means 1 mole, 1 mole, 1 mole, length 1 centimeter. And therefore, this is known as the molar extinction coefficient. Now, both laws are applied. Just see here, if BS law and numbers law both are applied, this is the A equal this much. And according to number law, A is equal to log I value upon I. This is the one value. This is the second equation. What can happen? You can say C epsilon dot C L it is equal to log I value upon I. This is the combination. You can determine epsilon. So in this way, these two laws are very important to understand the absorption of light by the compound, organic compound. Now, after this, we shall explain to what happens when light is absorbed by the molecule or the organic compound. So everybody knows that there are different energy levels in the molecule. Every molecule has a electronic state. In every electronic state, there are number of the vibrational state. Why there are vibrational state? Because atoms in the molecule, they vibrate like this. So that creates a vibrational state of energy. Now second, in every vibrational state, there are number of the rotational states. That is the energy produced by the rotation of the atom in the molecule, corresponding to each other. But in UV spectra, we are not concerned about the vibrational energy and rotational energy. Why? Because the energy of the absorbed radiation is very high. Energy of the absorbed light is very high. That is from 200 nm to 400 nm. High energy. So if there is a high energy wavelength is absorbed by the molecule, the transition will take place from one electronic state to another electronic state. So there are different types of the bond. You can say electron may jump from bonding to anti-bonding of one type. Suppose there is a sigma bond, so sigma bond, electron may jump to sigma bond to sigma star bond. We shall discuss it. If the electron is present in pi bond, if the bond is double bond or triple bond, there are pi bond. So a pi electron may jump to pi star. If the compound having heteroatom like oxygen, nitrogen, sulfur, for example, CO group, there's in the CO group C double bond O is heteroatom having unpaired electron. So unpaired electron that is present in non-bonding molecular orbital. So we shall discuss how there is a transition of electron takes place from one molecular orbital to another molecular orbital. Means from bonding molecular to anti-bonding molecular, means sigma to sigma star, pi to pi star, n to pi star, n to sigma star. So there are different types of the electronic transition, and therefore we can say this UV spectra is one of the electronic spectra, in which there is a transition of electron from one molecular orbital to another molecular orbital takes place. So in next lecture we shall discuss about the different type of the transition which are made by the absorption of electromagnetic radiation by organic molecule. Thank you very much. Thank you.